Welcome to the lessons on covalent bonding. Let us recap what is covalent bond. It is the sharing of electrons between atoms. So now we learn the dot and cross diagram. First, we have a chlorine atom where the circle or the dot represents the valence electrons, and another where the cross represents the valence electrons. When the two chlorine atoms join together to form chlorine gas, the sharing of one pair of electrons will form a single covalent bond. So the bar between the chlorine atoms will represent a single covalent bond. For the oxygen atom, the cross represents the valence electrons, and another where the circle or the dot represents the valence electrons. The joining of the two oxygen atoms will form the oxygen gas, and the sharing of two pairs of electrons will form the double covalent bonds. These can be represented by two bars between the oxygen atoms. So for the nitrogen atom, the valence electrons is represented by the cross, and another where the circle or the dot represents the valence electrons. The joining of the two nitrogen atoms will form nitrogen gas, and the sharing of three pairs of electrons will form triple covalent bonds. This can be represented by the three bars between the nitrogen atoms. So in summary, there are three types of covalent bonds: the single, double, and triple, and the various examples. Now we look at simple molecular structure. These are the chlorine molecules. Between the chlorine atoms, there is strong covalent bond, where large amount of energy is required to overcome the strong forces of attraction. Now we take a look at the keywords here. Large amount of energy, overcome, strong forces of attraction. Between the molecules, we have weak intermolecular forces of attraction, where little amount of energy is required to overcome the weak intermolecular forces of attraction. So it's little amount of energy, overcome, weak intermolecular forces of attraction. So in summary, for weak forces of attraction, little amount of energy is required to overcome the forces. For strong, large amount of energy is required to overcome the forces of attraction. So for giant molecular structure, we take a look at this example where a carbon atom has 4 valence electrons, and it is bonded to 4 other carbon atoms. This is how the carbon molecule looks like. When it's repeated in the long chain, it will form diamond, which has a 3-dimensional structure, which is tetrahedral. So comparing a simple molecular structure, it has weak intermolecular forces of attraction between the molecules, while giant molecular structure has strong covalent bonds between the atoms. For simple molecular structure, little amount of energy is required to overcome the weak forces of attraction, which will lead to low melting and boiling points. For giant molecular structure, large amount of energy is required to overcome the strong forces of attraction, which will lead to high melting and boiling points. So in summary, there are two types of molecular structure, simple or giant. For simple, little amount of energy is required to overcome the weak forces of attraction, hence there's low melting and boiling point. For giant molecular structure, large amount of energy is required to overcome the strong forces of attraction, hence there's high melting and boiling point. That's the end of today's lesson. Thank you.